Dewdrops and Rainbows, a presentation by Swantu Win. Let's start off with asking, what are dewdrops? We've all seen them on the surface of flower petals, spider webs, and leaves, but what exactly are they? Well, dewdrops are naturally occurring water droplets that result from accumulation of rain or the condensation of water vapor. The condensation of water vapor occurs normally on clear, warm nights where the temperature of the water vapor is warmer than that of the surface. So, when water vapor comes into contact with the surface, heat is transferred, lowering the temperature of the water vapor. As a result, the water vapor condenses and voila! Dewdrops are formed. Dewdrops vary in size, but generally do not exceed half a centimeter in diameter. This is due to the property of surface tension. Surface tension is basically the ability of water to bind to itself, therefore meaning that a water droplet, or dewdrop, can only be of a certain size before the surface breaks and it loses its shape. Examples are to the right. Due to their spherical and sometimes dome-like shape, dewdrops distort images much like the fisheye effect in photographic lenses, or the visual phenomenon experienced by looking through a peephole on a door. Dewdrops, like prisms, also refract light, and depending on how light reacts, several different types of rainbows can occur. They include primary rainbows, secondary rainbows, supernumerary rainbows, sunset rainbows, lunar rainbows, and of course, ring rainbows. Primary rainbows are the most common type of rainbow. They occur when sunlight enters a dewdrop and is reflected and then refracted into the spectrum of visible light. The path of light generally makes a 42-degree angle from entry to exit. Secondary rainbows, or double rainbows, occur when sunlight is refracted twice, creating two bands instead of the usual one. Second band is fainter and lies above the brighter one. Colors are also usually in the opposite order. Supernumerary or spurious rainbows occur in a similar fashion. However, instead of the sunlight being refracted twice, there's interference or incomplete refraction. So instead of a full second band, there's an additional bluish hue in the bottom of the rainbow. Sunset or red rainbows occur near dusk. They are the widest of the types of rainbows. The reason why sunset rainbows appear more red is because near dusk, sunlight contains more red light due to atmospheric scattering. This has to do with the positioning of the sun, as sunlight has to travel a greater distance through the atmosphere. Lunar rainbows occur at night. Instead of sunlight, lunar rainbows are produced by the refraction of moonlight. Since light from the moon is not as strong as light from the sun, lunar rainbows appear more muted. Lastly, there are ring rainbows. Ring rainbows occur like primary rainbows, only sunlight is refracted through dewdrops in clouds, rather than those on the surface of the earth. This creates a complete band around the sun, with red being in the center. To end the presentation, here are some things to consider about dewdrops and rainbows. When drawing dewdrops, be aware of edges and color. Don't make the edges too prominent, or the color too saturated. Dewdrops are supposed to be transparent, and their color should reflect the surface that they're on, or in front of. As for rainbows, remember that they're figments of light. Don't make them more saturated than they need to be. Also, although the angle of the rainbow depends on the dewdrop's position relative to sunlight, rainbows are generally perfect circles if they are complete. Consider the ring rainbow to be a perfect rainbow. Lastly, remember, when in doubt, always squint.